Hi, my name is John. Welcome to the third part in review of this Artec I-180 inverter MIG welder. I brought the welder out of my garage into the top of my garden where I've got another workshop where I do casting and welding and grinding. I do it like welding next to my machine tools. All the welding you see today will be with 0.6mm wire. I'll be welding between 1 and 1.6mm plate, normal car plate, possibly something slightly thicker. I have got some rusty metal, a rusty exhaust. I'll do some welding on that to show you it will do real world welding on rusty metal, not just nice clean welding on a bench. I'll do lap joints, butt joints, do an inside corner joint, what they call a rosette weld, which is like a spot weld. That's used quite a lot in car repairs. You need a pair of side cutters when you have MIG welding. You can buy proper MIG welding pliers, but ordinary side cutters do. And what you must do before you start to weld, you've got to trim the excess wire off closer to the tip. Then when you start welding, nice and clean. If you leave the wire sticking out too long, you get a horrible pop noise and it doesn't start welding as clean. Once you've finished welding, if you stop, and hold the torch just above the weld, it actually burns the wire off to the correct length. The welder has got built-in burn back. What happens is the wire stops feeding instantly and the wire actually burns back to the correct length to start welding again. It also has a gas purge which runs for 2 or 3 seconds after you stop welding, so you get a nice clean finish to your weld. I've got a fillet joint set up. This is 1.6mm mild steel plate, hot roll plate. The sort of plate it used for repairing chassis, heavy section sails. I'll zoom in, run a weld bead down it and see what sort of result we can get. I'll turn it over so you can have a look. That's right through, but not actually blown through, but it's going all the way through. That's the setting I'm using for welding that 1.6mm plate. I want a MIG180 at work, a MIG180 180. It's a transformer welder. It's a good welder, but it hasn't got the stepped voltage control this one has. I think it goes 1 to 6. And for welding that sort of material, which is what I weld all the time, you need to be on a position of 3.5, which it hasn't got. 3 is not quite enough. And 4 is just a little bit too much. But that setting there for welding that 1.6mm plate with a 0.6 wire is absolutely ideal. I've got a lap joint set up in 1mm plate. This is a very common joint when you're repairing cars. This is the setting I'm using for 1mm plate. It's quite a nice weld. If anything, there's a little bit too much build up on it. I'll turn it over and see what sort of penetration we've achieved. That's it there. It's all the way through. It hasn't blown holes through, but it has gone all the way through. And that was welded at the same current, but slightly less wire. You can see the weld isn't quite as raised as the other one. I've got 2 bits of, it's 1mm plate clamped together, and I've drilled 1/4" holes in. The plate's actually up off the surface plate, so it hasn't got a support on the back. Which, like if you're going to put a patch onto a sail or a chassis leg, you don't want to call a plug weld or a rosette weld. That's similar to a spot weld, except you do it all from one side. All you do, you start the weld in the centre of the base piece and weld round until it becomes one solid piece. What I'll do, I'll try and zoom in and see if I can get a close-up shot of doing one of these welds that are a very popular weld in the motor trade. I'll also try and demonstrate how strong one of those welds can be. you can see that not a bad looking weld. If we turn it over, 100% penetration right through, that'll be strong. I'll do one more. What I'll do a test on that weld, see how strong it actually is. Right, that's 1 6mm spot weld in 1mm plate. You've just seen us weld it. We'll put a bit of a weight test on it. Right, I'm fairly heavy. We've got one 6mm spot weld, and that's taking all my weight, no problem at all. Right, 1 6mm spot weld, no problem at all. I've got a bit of rusty exhaust pipe here, it's fairly thin. I've actually cut the flange off, but flanges often crack off and you've got to weld them back on. I'm going to weld straight through the rust. I won't clean this. The only part I clean is where the earth goes. So I'm still using 1.6 wire. We'll see if we can get that welded back on. We'll just get a tack on it first to hold it in place. About there. Right, I'll zoom the camera in and see how it copes with rusty metal. You can see even on rusty metal you don't get a great lot of spatter. I'll just turn it up a little bit. I'll try pulling it so you can see better. Touch more wire. You can adjust it to a very, very fine degree. Right, you can see I've got a good gap there. That must be at least a 3 or 4mm gap. That's how I can fill the gap in. MIG's particularly good for that. When you're filling gaps in, it's easier to pull the weld. Manual pulse. Down through. You can break big gaps with it. Considering it's rusty metal, that's a reasonable job. And that's filled a 3 or 4mm gap in, no problem at all. This is actual real world welding, rusty exhausts. Except it's on a bench normally, it will be upside down. Right, I've got it set up in the vise so it's like above my head sort of style, where you want to try and weld it on a car. Yeah, I've got a good earth. I think that's as far as I would go on 0.6 wire. In the next video I'll put the 0.8 wire in, turn it right up, see what it'll actually weld. I'll also be putting some MMA cables onto it and doing some stick welding, because I do like stick welding. If there's anything I've left out, anyone who wants to cover on the welder or show on the welder, just ask us. Just post a comment on the YouTube and I'll try and do it for you. Anyway, thanks for watching. Oh John, you old bastard. Right, 1 6mm spot weld.